बीएससी से रिलेटेड वीडियो पाने के लिए हमारे इस चैनल को सब्सक्राइब करें और बेल आइकन को दबाएं।
Hello guys, and in this lecture we'll talk about Henderson-Hasselbalch equation. And if you are a student of BSc chemistry as well as biochemistry, then this video is equally important for you, because from these topics generally questions come in your exam, numerical portion as well as derivation portion. So let's talk about Henderson-Hasselbalch equation. So this Henderson-Hasselbalch equation used to find pH of buffer solution as well as pOH of buffer solution. So when we derive Henderson-Hasselbalch equation, then final derivation is our, that is pH equals to pKa, means dissociation constant of acid, plus log A minus, that is conjugate base, and that is acid. So when we know that is dissociation constant of acid as well as this concentration of acid and concentration of conjugate base, then we can easily find out the pH value of given buffer solution. Then after pOH, so pOH equals to pKb. pKb means dissociation constant for base, and plus log B plus by BOH, and this B plus means conjugate acid, and this is the concentration of conjugate base. Bracket represented for concentration and generally expressed in normalities. Okay, so let's talk here. So this bracket represent concentration. So let's derive this equation, Henderson-Hasselbalch equation, and you know there are two conditions for acid, for base. So for acid we have to find pH, for base we have to find pOH. So let's talk here, that is one by one. Okay, first one is for acid. Okay, so here I am making two columns. Okay, so for acid. Okay, so for acid, acidic buffer. So for acidic buffer solution, so let us consider a weak acid, that is Ha. So this Ha dissociates into H plus plus A minus. So this Ha dissociates into H plus and A minus. So this is acid. So when we write here Ka, that is equilibrium constant of acid, then what can I write here? That is H plus, and concentration of H plus and concentration of A minus divided by this Ha. So Ha. Okay, right? So Hc. So now we have to find pH. So pH. So first find value of H plus, because you know pH equals to what? Minus log H plus concentration. So minus log H plus. So first find here H plus. So that is H plus here from this Ka into Ha divided by A minus. So Ka into Ha by A minus. So taking minus log on both sides. So taking minus log on both sides, that is minus log, that is because pH equals to minus log H. So here H plus. Now minus log H plus, taking minus log on both sides. So okay, first take log on both sides. So log, that is H plus, don't confuse, and that is log Ka into Ha concentration by A minus concentration. So if you remember the formula, that is log A into B, that is log A into B equals to log A plus log B. Simple. So use this formula here, that is log H plus equals to what? Log A, that is Ka, plus log B, log Ha by A minus. So this is here. Okay, so just erase it. Okay, so write this first of all. Okay, so we have to find here pH. So pH equals to minus log H plus. So taking minus on both sides, that is what minus log here, minus log H plus, and that is equals to here minus, that is minus log Ka, and minus log Ha by A minus. Okay, so this is minus by A minus. Okay, so minus log H plus equals to pH. So pH is equals to, that is, and if you remember this formula one time, so pKa equals to minus log Ka. So minus log Aka, in case of minus log Ka, here you can write pKa, that is the dissociation constant for acid, and minus log same HA by A minus. Okay, so HA by A minus. So when I reverse this here, when I reverse this term, then what we get, that is pH equals to pKa plus log A minus by HA, and this is the final equation for acid, that is pH equals to pKa plus log A minus by HA. So when we know the dissociation constant of acid and concentration of conjugate base and acid, then we can find easily pH of given buffer solution. So let's talk about then after POS, that is for basic buffer. So for basic buffer. Okay, so for basic buffer. So consider here a weak base, that is BOS. So this dissociates into here B plus plus OH minus. So here base, so constant for base, that is KB equals to B plus concentration and OH minus concentration divided by BOH. So we have to find here, that is POH, and you know POH equals to minus log OH minus. Okay, so first find OH minus, so that is OH minus is equals to, that is KB into BOH by B plus, from this equation. Okay, B plus, so taking log both sides, that is log OH minus is equals to what? Log, so log A into B, the log A plus log B, direct formula. Okay, so when you write, that is POH equals to minus log OH minus, so here taking minus on both sides, that is minus log OH minus is equals to minus log KB minus log, that is BOH by B plus, here concentration this one, and when we put here, you know, POH equals to minus log H plus, so that is POH equals to, and PKB equals to minus log KB. So in case of minus log KB, what can I write? PKB, that is dissociation constant for base, and when I reverse this term, that is log, this one go numerator and this one come to denominator. Okay, so finally what we get here, that is POH equals to PKB plus log here B plus by BOH. Okay, so in this way you can find the POH of basic, that is buffer solution, as well as